We're going to look at the first operation, that is nothing but insert in try. Insert s in try. Before that, we know, right? This is what our structure of try was. This was our class try, where we had multiple members, one children array, one ended variable, which was Boolean type, one was visited member, which was integer type. Of course, we're initializing it. Yes. Now, let us say, let's come back to one real time example where we are trying to insert, actually trying to insert a word here, ABC. Yes, we know to make any operation, root should be there, is it right? So first operation should be declare root. It should be the default values initially. There will be one root visited member who has value as 0. Yes. When we are when we are trying to insert ABC, we said whenever we are trying to insert ABC, the first letter A, that means from in the root, the A letter will be active. What is active means? It should not be null. It should be holding one more try node. Is that right? Yes, one more try node. That means if you have A, first question is how to get the 0th index. This is what we said. Is that right? A means 0th index, B means 1th index, C means 2th index, so on. Z means 25th index. So this one mapping we require. A to 0. If you have B, get 1. If you have C, get 2. So on. If you have Z, you should get 25. And we can get it very easily. Is it right? It's just ASCII value. So you'll if you simply say A minus A, you'll get as 0. Yes, that means from any character, see if you subtract the base. Yes, base is nothing but the first starting ASCII value of A. This will give you answer as 2. Yes, so whatever the current character is, just subtract A from that. You will get the index value itself. Yes, so to get the index value, index will be nothing but if I say S of I minus A. Yes, this is what your index will be to just get the index. Yes, now at this particular index, assuming S of I is just A for us, is it right? From this, we said here we have to create a new node, new try node. So what will you do that? So I will say root dot children. Focus here what I'm writing. Root dot children. Remember, child was our member. Children of index. Index means 0. Here we are saying create a new try node. Yes, what will happen after this? Just focus. After this, what will happen is a new try node will be created again, which will have the same members. One is ended, one array, and one visited. Again with the default values null. Yes. Now what we need to do? A is inserted. We said we have to insert B. Where we have to insert B? In the Ath node, B has to be inserted. But what should you do here? Should you say you have to get your root over here to insert next value on the Bth node? No, you cannot do that. Is that right? You cannot change the position of root. That means to keep track of last inserted node, you will also use one more variable which is temporary. Yes, which is nothing but one more pointer to the root node, which will help us to keep track of newer nodes so that we can append other nodes after that. So whenever you create a new node, this is where your temporary will be. So what will you do? Just focus here. That means temporary will be equal to root dot child of index. Yes, we have changed the position, right? Initially temporary was at root. Remember, temporary was at root. After you have created a new node, you'll simply say go there. Is it right? Go to there. Now, we'll repeat the same process again. These process has to be repeated. You should agree because what we did was just for the workhorse operator. What we'll be doing is just go for all the indexes. I less than s dot length and I plus plus. This is what we'll be doing, guys. And remember, temporary was initially equal to root. Yes. Now, assume I have inserted ABC and I want to insert A, B, E here. My first question is, do we need to create a new node here? Answer is no to that. Is that right? Answer is no to that. So first thing, I should create a new node only if it does not exist. Yes, so there should be a if check here. We are trying to implement it simply. Let me write it. We should implement this only if it does not exist. That means if root dot child of index. That means I'm trying to insert a new node A. I should check. If it is not equal to null, only then insert it. Only then create a new node. Is that right? Now, after this, we said there are multiple members. First member was visited. That means whenever I am currently at a node, I should increment it also. Yes, that means after this if condition, it will make sure that temporary is always there. Is it right? The next node is always there. So what you will check? Temporary dot visited, you will simply say plus plus. That means this node I have visited for the first time. Yes, after the word is inserted, you should also specify it is ended also. Is that right? That means wherever the current temporary is, you will simply say just make the ended as true. Yes.